Much. It's really nice to be here again. As I said, as Daniel has said, it's been before mostly presenting about technologies, about or one technology, especially SEMS, and I'm also co-founder of Frafos, which is has a session border controller as a product. But this time I want to present about something different. This is application of open source to a specific problem. And the wider context is that the question, I think...
Fix it.
Thank you very much.
Say something, say hello.
Hello? Hi. Good. The bigger question is whether we are able to build infrastructure, telecommunication infrastructure, also as community infrastructure, whether the traditional model where big companies have to invest loads of money to build up infrastructure and then have to somehow recover that investment, whether this is the only way or whether we can also make it possible that people come together and own their own infrastructure. And I've been really lucky to be able to work with some organizations which do research and development in this area. The logos are down here, and I'll first want to present what they are doing a little bit. First one is Rhizomatica and TIC AC. They work mostly in Mexico, but also in other Latin American countries. And their mission statement I put down here. I'll just read it because I really like what they're doing. Rhizomatica supports communities who need or want to build and maintain self-governed and self-owned telecommunications infrastructure. Yeah? And so they are really going and they are putting up GSM masts. Yeah? And they are helping people, especially they are not putting them up, but they are helping people to put them up themselves. Yeah? So they help a village to come together and put a GSM mast. And here's a map of the south of Mexico, and the dots show where they have connected villages, where they have helped people to establish their own phone networks. And now the question why in the south of Mexico, and here's this more in detail where these villages are. And one reason is that the GSM coverage over there is really low. So you see all the GSM BTSs here, and in the middle there's nothing. And as you can see, this area is has a lot of mountains, and there's not so many people living there, and it's relatively poor. So people don't have a lot of money to spend on telecommunication. So they are also mostly indigenous people, and they got the right, because they have the right in the Mexican constitution of self-governance, so they also got the right to govern their own spectrum, which is a very important component, which makes it difficult to do similar things in many other countries. And so they've been able to support people to actually do what you can see here, that they've been able to use their phones in this remote mountainous villages. Another organization is Cellular, and they are working mostly in Nicaragua, but they're also doing research and development projects for other countries, and also some African countries. And in Pearl Lagoon, they're running a network which also has like 2 BTSs over there. Now, if you want to connect these community cellular networks, so I call them CCNs, community cellular networks, if you want to connect them to the PSTN, you usually have the problem that you can't peer directly, because getting these PSTN numbers is very expensive. So they would pay maybe $1 per month already only for the PSTN number, unless they can do other forms of peering. And so what they normally have is they have one SIP trunk with an inbound access number, like a pilot number, and then people from the PSTN, so their relatives in the city, they can call in, and they then type the extension, and then they are connected on the internal infrastructure to the community cellular network. They have an uplink, they have internet uplinks from the villages to one data center, and they route the calls over this anyway. So everyone who's working in telecommunication now thinks, okay, but actually this is all internet, so why can't we connect them directly? And this is what we wanted to do. So we wanted to make a dialer application for which, or with which people can simply directly text and call people. And especially with text, with SMS text, it's problematic in this approach, because you only have one number, so you can't text, you can't send text messages there. Yeah? So if the internet uplink is down, they can call internally also, yeah? And they can send text messages internally, but you can't send text to a mobile network, and the mobile networks can't send text back. So the idea was to make a dialer application that goes over the internet directly and can also send text messages to the people. The requirements quickly here, it should be really easy to use. So people who are not telecommunications engineers, they should be able to use it without typing in some zip, blah, 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 and blah, blah. And also to set it up. And it should also work on old smartphones. And so it should be lightweight. And the implementation should also be somehow accessible so people can join the project easily. So also people over there, I mean, I think it doesn't make sense if like really highly specialized engineers only can work on this, but everyone has to be able to join and contribute. Huh? So for a VoIP application, there's basically two big options how to go. For a mobile application, a native application or a web application. For a native, we can adapt an existing application, which is quite feature-rich, like CSIP simple. But then you also have to make it run on different phone models and iOS and so on. And you need a lot of specialist knowledge. The other way is to use a web application, and now we have WebRTC. We have all this nice new web technology. We have WebRTC for the VoIP stack. Yeah? And you have to test it basically only on Chrome and Firefox and Safari. So what is a progressive web app technology that we use, or this PWA, is basically, like from my old school point of view, it's just a normal website where the application is written in JavaScript, and it has this add to home screen functionality, which makes that the application is cached, so it loads quickly and without big transfer. And you have these service workers, which is JavaScript functions, to control cache or to push notifications and do everything. Yeah? And you can use this in-browser database to store data on the phone, basically. The other big part of technology is WebRTC, which we probably all know about. What is nice here is that the VoIP stack that you've got in the phone is really good, actually. So, I mean, it's like some of the best packet loss concealment and echo cancellation, and all that is really implemented very, very well. And we use the GSZIP library because we knew it, and it's easy to interoperate with ZIP networks. Huh? So the whole system looks like this, gateway, which does ZIP to WebRTC, because on the other side we speak ZIP to the BSC. And then you have user registrations and push notifications to notify an incoming call. Yeah? And for SMS, we just use ZIP message. In detail, we made it very simple. We put a Let's Encrypt certificate, made Apache to serve the website, and we speak from this JavaScript app, which is an Angular app, to Kamailio and RDP engine. Yeah? And to sign up, we also made it very simple. The application calls a script that just calls the CamCTL, yeah, and allocates a number. And For the push notifications, for now we have to integrate with the Google push notification service, and there's a separate web push server, small node-based server that does the interaction with actually the push notification. Yeah? And also the registration in the other way, because you need the device identifier to actually send the push notification. Then we thought, how do we make it possible that other people can collaborate with this project easily without having to set up like hundreds of different components manually? And so we had as target a complete install with one line, and we had we created Docker Compose files for the server, so you can set up the Docker Compose with basically 1 or 2 lines. If you have a DNS entry, it's still not 100% complete, but it's mostly represents what we are using in production as well. Just want to show, I forgot about this. Just want to show what the dialer app looks like. So you have a call, and then here my number is on the top, and the directory, now this is for the PerlCell deployment, where they have some numbers, and you can add people into a contact list, and also share, and just can call people there. So just some interesting learnings from that. The pure web application has some limits, yeah? So you can't access the phone book properly, and you can't select whether, or on my phone at least, whether to use earphone and speaker. There's just no Android API for it. And push notifications are always a little bit trickier, and we are thinking about using a small native wrapper around the web application that to maybe control it a little bit better. Yeah? Also, this combination of the web and the telecom worlds is a little bit tricky, because the release methods and cycles and changes are always a bit different, and an agile development style is really useful for it, I think. And I also have to say that to get a really polished user experience is really not easy. There's many little details, even in an application that looks as simple as this one. Yeah? In the future, we want to do offline developments, or we want to make it possible also for offline developments for Wi-Fi mesh networks, also with HF backhaul, where most of the Rhizomatica team is at the moment working on. And also to find so this also means we need to find an alternative to the Google push notifications, because obviously you can't use them offline. And also to really implement the texting part, which is only in a branch for the moment. And I think, so this whole project is quite interesting, because it combines some things that might be interesting for many other people that are developing on or implementing VoIP networks and WebRTC and internet. So whole WebRTC gateway integration with RTP engine, push notifications, the Kamailio script itself, the JavaScript application. Everything might be interesting also for other people. So that's why I want to invite you also to come and join and contribute to it or use it. And yeah, here's some links.
Okay, thank you, Stefan. One questions. One of you, a question. Anyone? My question about this, it's always how do you got on all these projects any kind of pushback or let's say barriers from telecom guys or the mobile operators in those countries? Because it typically, from my experience, was something like, okay, I don't want to deploy there because it doesn't make money for me, doesn't worth the investment, but also I would like nobody else to do it.
Yeah. I mean, I've joined this only last year, actually, so I haven't been part of the earlier times when they actually built up the GSM networks themselves. What I know is that they had problems when their network because it accepts all the handsets, and it doesn't look whether one handset is part of the network or not. So then if the signal of that network is stronger, then other people who might have signal in some places from a far remote BTS, it gets actually taken into that network, and they lose the connectivity to the commercial network, and then people are saying, oh no, you are disturbing our service, even though it's very low signal. So that's one problem. There's also a lot of politics going on and political things, whether they are able to do it is in, I think they had to stop doing this in one village at least because a commercial operator was coming there, and then somehow the whole situation changed. Yeah.
Okay. Okay, thank you, Stefan. And getting Mr. Bode up front here.